Hello, I'm Alex Brown, and I'd like to introduce you to the PinTail Anchor and Threaded Rod Design Tool. This tool takes you behind the scenes of our published literature for PinTail Anchor capacity, allowing you to dial in your PinTail and Dovetail deck slab for both hanging and bracing capability. Let's jump in. First thing I want to point to are the two tabs across the top here. This first one for bracing, and then hanging as well. So you may ask, what's the difference? Bracing is going to be anything at an angle. So that's going to incorporate both a vertical hanging gravity load or a shear horizontal load. A couple of different inputs that is controlled right here. We'll get to all of those in a second here. And then the hanging tab, that's going to be gravity only. So anything that's pulling straight down can be analyzed here. There's a print button up here in the top right. It's on both hanging and bracing, and this is going to give a really good summary of all the inputs, all the outputs, all the graphics, and in particular, all the calculations that are fueling this entire tool. So all of these images are updated dynamically based on the inputs. So you can see at the bottom here, just a little diagram showing how the anchor fits inside of the dovetail deck with the concrete. And then all of the other hardware is labeled 3/8 rod, nut, split lock washer, etc. So that gives a really good snapshot of the overall assembly and what all needs to show up on the job site to properly supply it and install it. And then the graph updates as well to show the different checks that are happening between the rod, the anchor itself, and then this green line here, force at any angle. That's just showing what that capacity is as the V and the P change. And then that green there is the apex of that curve, which is right at the green line of capacity. So we'll play with all of those here over the next few minutes. So looking at the inputs themselves here, working from top to bottom, the very top is not an input. That's a read-only field, just showing the designation of the PinTail Anchor. So 2.0 is for 2.0. That corresponds to the deck type. We've got a 2-inch and a 3.5-inch dovetail profile. Both are available. PT for PinTail. And then that 3 corresponds to the rod size. So that is 3/8. And if we were to update that to 1/2 inch, that's a 4 for 4/8. Next, we can label this to be a specific area if we're looking at just part of a project, or you can put a project name in there. ASD and LRFD, both supported. Deck type, just to dwell on this for a second here. For the nomenclature that Vulcraft and Verco are using, 2.0 is 2 inches, 3.5, 3.5 inches. D is for dovetail. And then S and F stand for stiffened and flat. So those are two alternate versions of the different depths. So 4 profiles total to pick from. And stiffened versus flat is going to have some different load capacities and some different uses within different projects. Dash 30 and dash 24 is the width of an individual sheet of deck in inches. So the 2-inch deck is available in a 30-inch wide sheet, and our 3.5-inch is available in 24-inch wide sheets. FL stands for form lock. That's our label for a floor dovetail deck profile. We'll just leave that in a 2-inch profile for now. Concrete strength can be modified here. Rod size and the grade of steel used, all of that can be controlled here with these drop downs. And then the anchor spacing, this is another one I want to spend a moment on because it's really important for getting the most capacity out of the anchor is properly spacing them apart. So it defaults to 6 inches here, but you can see from that tooltip that I've got popped up there below my cursor, for a 2.0 PT, so a 2-inch pintail, minimum spacing for full capacity is 9.375 inches. So the 6-inch spacing that's defaulted here is not giving us the full capacity of this assembly. And then for a 3.5-inch pintail and deck, that minimum spacing is almost 3 foot, 34.375 inches. There's definitely some play there where everything kind of dynamically feeds into what the capacity is, and that's why this tool exists in the first place. It's a little more complicated than something that can just be printed in a table. And then just to play with some of this here, if I want to put these things really close together, 1 inch apart, well, I actually get an error message because the 2.38 inches is the physical width of the anchor itself. They can't be physically closer than that. So that's the minimum dimension that the tool accepts. And if I flip that over to a 3.5 inch profile, that anchor is about twice as big, 4.134 inches. So that pops up in the message here. So I'll put that back at 6 inches for now. And then the load input type here, so force at any angle is the most conservative approach. So that's basically saying, in this example here, I've got 450 pounds of capacity, and I can pull that any which direction I want in relation to the anchor here. But if I want to dial that in a little bit more precisely, I certainly can. Force at an angle allows me to specify what that force is at what kind of an angle relative to the horizontal deck, or combined forces where I can just give the specific components, my vertical and my horizontal, I can just punch those in directly. Jumping over to the hanging tab, a lot of the same inputs here, but it's a little more straightforward because it's not dealing with some of the angle checks or having to deal with a shear force interacting with the vertical. So this is vertical only, so you describe the area, the deck, the concrete, the rod type, the spacing, all of that is here, and then it just tells you what the maximum allowable tension strength is of that condition. So let's jump into an example. We'll go back to the bracing tab here, and I'll just refresh my page quickly to get to all of the default values again here, just so I'm kind of starting with a blank slate a little bit. So you can see our maximum force here is 390 pounds. So let's see if we can get some more capacity out of this assembly here. First thing I'll look at is the concrete strength. So that defaults to 3,000 PSI. If I bump that up to 4,000 PSI, now I'm getting about 450 pounds of capacity. So that's cool, but maybe that's not quite enough. So let's play with the spacing here. Again, that defaults to just 6 inches as kind of an arbitrary starting point. If we bump that up to 8 inches, you can see I get a little bit more capacity there, the 479. And then if I want to take that up to that minimum spacing for full capacity, let's just say 10 inches, I'm up to almost 500 pounds. So again, force at any angle is a touch conservative, so let's dial that in. You know, maybe on this project, the thing that's generating this load that we're trying to take up into our deck slab, maybe it's a brace, a seismic bracing member of some sort that's attaching to an adjacent column. So something like that, we know that location. We know what kind of an angle it's going to come into the deck at. So we can dial that in a little bit further. So let's say we've got a 300-pound load coming in at a 45-degree angle. I'll just change that to 8 inches just to take it back to that earlier number we were using. So you can see here we've got plenty of capacity. Our applied force is way down here, well within the envelope that our PinTail Anchor is setting here. The rod has a bunch of capacity. It's way out here, not even 20% stressed. So the anchor is about 60% stressed. Let's see if we can max that out and kind of find sort of where that limit is. So if we bump our load up to 500 pounds, oof, now we're right there. We're just past the line a little bit. And I can check up here and see my ratio is no good. I'm over my 1.0 limit. So maybe this is something I modify the design, the configuration of the project a little bit. And that 45-degree angle, maybe I can take that to 60. So in this case, because it's measuring, our 0 is the horizontal of the deck, increasing that angle forces the load to be pointed downward a little bit more. So it's going to be a little more hanging, a little less horizontal shear on that anchor. And because of that change, you can see that our applied force is now under our anchor capacity. My ratio is 0.912, about 91%. Perfect, beautiful, I'm comfortable with that. Then there was one more option, the combined forces. So just to step through that here, one thing I want to point out, it did save my 560 inputs here, but now it's treating them as my vertical load and my horizontal load. So definitely something to keep an eye on if you're switching between input types. But here, it works very similarly. I can change these different loads here. My graph is updating dynamically. It's very powerfully showing kind of what the capacity of this assembly is here. So let's jump over to the hanging tab, do a quick example there. So that first example, we were using the 2-inch dovetail deck. Let's go ahead and use a 3.5 inch just to switch it up. So we'll use the stiffened profile, that S. And you can see here, because it's a hefty deck, it's a lot deeper. The PinTail Anchor is a lot beefier. I've got a lot more capacity. We're talking thousands of pounds rather than hundreds. So a little over 2,000 pounds of tension strength here. But maybe we need it to be a little bit heavier. So let's try bumping that up a little bit. Let's look at the rod. We can try playing with that variable. So it defaults to mild steel. If we bump that up to 836, you can see that gave me a fair amount more capacity, over 10% increase, almost 2,400 pounds. Awesome. Let's see what else I can get. That was a little disappointing. It was only about 20 pounds more. So I'm at this 2414 number here. My rod is maxed out. But what we can do is increase the size of it. So I'm at 3/8 inch. Let's bump it up to 1/2 inch. Nothing happened. How about 5/8? Still nothing happened. My image updated to reflect my new rod size. My max sprinkler pipe size updated. That's in accordance with NFPA 13. Well, that's cool, but I'm still stuck at this 2414 here. So the rod must not be governing the design. It's got to be something else, maybe the concrete. So if we kick that up, 4,000 PSI, there we go. Now I'm up almost to 2,800 pounds. And again, just like with bracing, the last variable that I could play with here is the spacing that I allow on my project. So this defaults to 24 inches for the hanging tab, but you can see that same tooltip there. If I want to increase my capacity further, I basically need to be 3 feet apart minimum. And then that took me way up again, 3,200 pounds. And that's the PinTail Anchor and Threaded Rod Design Tool. It's a great resource for fine-tuning your hanging or bracing scenarios, and it ultimately allows you to feel confident in specifying next-generation dovetail deck and PinTail anchors from Nucor Vulcraft Verco. And with that, happy specifying.